Part 1 of this video series introduced the primary flight controls, which includes the elevator, ailerons and spoilerons, and rudder. Secondary flight controls include trim and flaps. Take a closer look at the electrical and mechanical resources for trimming the TBM in all three axes. The TBM is designed with trim, a secondary flight control, which is used to neutralize these control forces in all three axes. Trim reduces the attention required of a pilot by holding the flight controls, essentially holding the airplane in a set flight position, reducing effort, reducing workload. Each phase of flight is accompanied by a new pitch attitude and frequently a power change. Maintaining an airplane in the coordinated flight position with the use of trim is essential. Pitch trim can be managed electrically via a thumb switch on the control wheel, which drives actuators that change the alignment between the pitch trim tab and the elevator. Aerodynamically, one can remove the force required to hold this primary flight control. Pitch trim can also be managed manually via an ergonomically placed control wheel on the center pedestal. Roll trim, or aileron trim, is manipulated via an electric trim switch, also located on the engine control pedestal. This switch drives an actuator in the left wing, which moves the left aileron trim tab, thus aerodynamically assisting with roll force. Rudder trim can effortlessly be controlled via an electric trim switch on the control wheel, which drives an actuator within the vertical stabilizer, which adjusts the angle of the rudder trim tab. Even TBMs equipped with yaw dampeners and/or auto trim function require system monitoring. Coordinated flight is determined via the flight instruments, while system status is presented within the flight mode annunciator panel and the crew alert system. If not managed properly, trim can also hold an airplane in an uncoordinated flight position. As an airplane, trim for a stabilized climb pitches over to enter straight and level flight, it will begin to accelerate towards design performance. During the acceleration, the propeller's left-turning tendencies, which were prominent during climb, begin to fade away. In order to maintain coordinated flight throughout the acceleration, a decreasing amount of right rudder force is required. Both rudder and rudder trim must be reset. Otherwise, the airplane will enter uncoordinated flight as it begins to yaw and bang to the right, a skidding turn. The error is obvious, for the airplane will immediately turn off course, and if left uncorrected, the nose will pitch below the horizon, and the airplane will begin to descend. A simple skid can be complicated further if one were to compensate for the changes in heading by rolling into the opposite direction, banking to the left, with ailerons. The aircraft would enter a cross-controlled situation referred to as a steady heading sideslip. A glance at the turn coordinator reveals the need for left rudder. Gently reducing right rudder force or trimming in left rudder pressure until the ball is centered will allow the aircraft to continue in straight and level coordinated flight. Pilots flying G1000 equipped TBM 850s and TBM 900s or G3000 equipped TBM 930s can simply reach up and select yaw dampener on, which activates auto trim functions. There is one proper way to deactivate the yaw damper, by depressing the soft key on the autopilot mode controller. The command is to be confirmed on the flight mode annunciator panel. If workload is high, for example just before landing, all autoflight functions, including yaw damper, can be deselected by pressing the red autopilot trim disconnect switch on the control wheel. On G1000 and G3000 equipped TBMs, if one were to inadvertently command left or right rudder trim, while the yaw dampener or auto trim is on, the system will disengage. With respect to trim and airmanship, there are three levels of awareness: unaware, reactive, and active. The unaware pilot allows an airplane to enter the next phase of flight without making or monitoring correct trim changes, allowing the airplane to enter uncoordinated flight. The reactive pilot will recognize asymmetric flight exists and return the aircraft to the coordinated flight position. An active pilot, however, anticipates and makes changes required to trim settings with each phase of flight. Coordinated flight is maintained throughout the maneuver. Loss of situational awareness is a hazardous behavior in the cockpit. With respect to the fundamentals of flight, an airplane may enter the next phase of flight with the inappropriate trim settings. Coordinated flight may be lost.